What if I told you there's a factory in Japan where robots don't just assemble cars, they assemble other robots, where humanoid machines work alongside humans, building the future with their own hands? This isn't science fiction. This is happening right now. And what you're about to see will change everything you thought you knew about manufacturing. In the next few minutes, you'll step inside one of the most advanced robotic factories on Earth. You'll witness humanoid robots performing tasks that seem almost human. You'll see AI-powered brains making split-second decisions. And you'll discover why this technology is about to transform every industry on the planet. But first, let me ask you something. Have you ever wondered who builds the robots that build our cars? Who assembles the machines that assemble everything else? The answer might surprise you, because in Japan, robots are now building robots. And the level of precision, speed, and intelligence involved is beyond anything you've seen before. We're standing outside a massive industrial complex in central Japan. From the outside, it looks like any other factory. But inside these walls, the future is being constructed piece by piece by machines that can think, learn, and adapt. This is where automation meets artificial intelligence. This is where the future works. As we step through the entrance, the first thing you notice is the sound, or rather, the lack of it. Unlike traditional factories filled with clanging metal and shouting workers, this place hums with quiet efficiency. Robots glide across the floor. Robotic arms move in perfect synchronization. And somewhere in the distance, a humanoid machine is learning a new task. This facility spans over 300,000 square feet. It operates 24 hours a day, 7 days a week. And here's the incredible part. More than 70% of the work is done by robots. Not just any robots. Humanoid robots. Machines designed to move, think, and problem solve like humans. But why humanoid? That's the question we need to answer. Traditional industrial robots are brilliant at repetitive tasks, but they're fixed in place. They can't adapt to new environments. They can't walk to a different workstation. Humanoid robots can. They can navigate spaces designed for humans. They can use tools made for human hands. And that makes them the most versatile machines ever created for manufacturing. Look at this. A humanoid robot standing at a workstation, holding a precision screwdriver. Its movements are smooth, almost graceful. It tilts its head slightly, analyzing a component in front of it. Then, with perfect accuracy, it inserts a tiny screw into a circuit board. The entire process takes 3 seconds. A human would take 8, and this robot will do it 10,000 times today without a single mistake. Now, here's a question for you. If a robot can do this job faster and more accurately than a human, does that mean humans are no longer needed? Keep watching, because the answer is far more interesting than you think, and it's not what the media tells you. Let's follow the production line from the very beginning. Every robot starts as raw materials: aluminum, steel, carbon fiber, silicon. These materials arrive at the factory in massive shipments. And the first robots you'll meet are the ones that sort, organize, and prepare everything for assembly. They work in teams, communicating wirelessly, coordinating every movement. Watch as a robot arm picks up a sheet of aluminum. It scans the surface with laser sensors, checking for imperfections. Within milliseconds, it categorizes a material and sends it to the next station. Another robot receives it, cuts it precise dimensions, and passes it forward. No human touches it. No human needs to. The system runs itself. Now we're entering the frame assembly zone. This is where the skeleton of a new robot begins to take shape. Humanoid robots stand at assembly stations, each one responsible for a specific section. One robot attaches the torso frame. Another secures the leg joints. A third calibrates the balance sensors. They work in perfect harmony, like a choreographed dance. But here's something that might shock you. How precise are these robots? We're talking about tolerances measured in microns. That's 1,000th of a millimeter. A human hair is about 70 microns wide. These robots work with accuracy far beyond human capability, and they do it hour after hour without fatigue, without error. Next, the robots install the actuators. These are the motors that will allow the new robot to move. Each joint requires a specific type of actuator. Stronger ones for the legs, more delicate ones for the fingers. The humanoid assemblers know exactly which part goes where. They've been trained using AI simulations, and they practice these movements millions of times in virtual environments before ever touching real components. Now comes one of the most complex steps: installing the wiring. Think of this as building the robot's nervous system. Thousands of tiny wires must be routed to the frame, connecting sensors, motors, and computer systems. A single misplaced wire could cause a catastrophic failure. But watch as a humanoid robot's fingers move with surgical precision, threading each wire through channels barely wider than the cable itself. Have you ever tried threading a needle? Imagine doing that 10,000 times a day, perfectly, every single time. That's what these robots do, and they're just getting started. If you're enjoying this journey inside the factory, consider subscribing. We're diving deeper into technologies that are reshaping our world, and you won't want to miss what's coming next. Sensors are the eyes and ears of a robot. In this section, humanoid workers install dozens of sensors into each new unit. Proximity sensors to avoid collisions, pressure sensors to control grip strength, gyroscopes for balance, cameras for vision. Each sensor must be calibrated to work perfectly with all the others, and the installation must be flawless. After sensor installation, each robot passes through an automated quality check station. Laser scanners examine every surface. Diagnostic software tests every connection. If even a single sensor is misaligned by a fraction of a degree, the system flags it. The humanoid assembler receives an alert, makes a correction, and the robot continues down the line. 0 defects. That's the standard. Now we reach the most fascinating part of the entire factory: the AI brain installation. This is where a robot transforms from a mechanical body into an intelligent being. The brain is a compact supercomputer, no larger than a lunchbox, but capable of processing billions of calculations per second. It's loaded with machine learning algorithms, trained on millions of scenarios. A humanoid robot carefully picks up the AI brain module. It aligns it with the mounting brackets inside the new robot's head. Connectors click into place. Power flows. And for the first time, the new robot systems come online. Status lights flicker. Diagnostic routines begin. The robot is waking up, and within seconds, it will be smarter than any machine from just 5 years ago. Here's a question that keeps scientists up at night. When does a machine stop being just a tool and start becoming something more? When it can learn, when it can adapt, when it can make decisions on its own. We're not here to answer that today. But as you watch these robots work, you might start wondering yourself, with the hardware complete, it's time for the software upload. The new robot is connected to the factory's central network. Terabytes of data flow into its brain. Movement libraries, object recognition databases, safety protocols, task-specific training modules. In less than 2 minutes, this robot receives the equivalent of years of human training. It knows how to walk, how to grip, how to see, and how to learn. And now, the moment of truth. The new robot's eyes activate. Its head turns slowly, scanning the environment. It lifts one arm, then the other, testing joint response. It takes a step forward, then another. The movements are cautious at first, like a newborn learning to walk. But within minutes, the robot is moving with confidence, ready to join the workforce. Before the robot can work, its vision system must be calibrated. It's placed in a testing chamber surrounded by reference objects, blocks of known size, colors, distances. The robot looks at each object, calculates its dimensions, compares the results to the database. If its measurements are accurate within 1 millimeter, it passes. If not, the system recalibrates automatically. Precision is everything. But here's where it gets truly amazing. The new robot doesn't just follow pre-programmed instructions. It learns. It's placed in a virtual simulation where it practices tasks thousands of times in accelerated time. Drop a part, learn from it. Miss a connection, adjust and try again. By the time this robot reaches the factory floor, it has already failed and succeeded more times than most humans do in a lifetime. Now you might be wondering, if robots are building robots, and those robots can learn and improve, Does that mean they'll eventually build even better robots than themselves? And where does that cycle end? Hold that thought, because we're about to explore exactly that. But first, let's talk about quality control. Every robot that leaves this factory must pass through the quality testing lab. This is where robots are pushed to their absolute limits. They lift heavy objects repeatedly to test actuator endurance. They navigate obstacle courses to test balance and coordination. They perform precision tasks to test dexterity. If they fail any test, they go back for adjustments. Only perfection leaves this facility. In one corner of the lab, a humanoid robot lifts a 20-kilogram weight over and over for hours. Engineers monitor motor temperature, power consumption, joint wear. The goal is to simulate years of work in just a few days. If a component is going to fail, better it happens here than in a customer's factory. Quality isn't checked. It's engineered into every single part. In another section, robots are tested on precision tasks. One robot must stack tiny blocks into a perfect tower. Another must thread a needle. A third must write the alphabet with a pen. These aren't just tricks. They demonstrate the robot's ability to control force, adjust grip, and coordinate complex movements, skills that will be essential in real-world applications. Now, let's address the big question. What about the humans? Are they being replaced? Walk with me to the control center, and you'll see the truth. Humans haven't been replaced. They've been elevated. In this factory, humans don't do repetitive labor. They design, supervise, troubleshoot, and innovate. They do what robots can't. Imagine the future. Inside the control center, human engineers monitor hundreds of screens. Each screen shows real-time data from robots across the factory: production rates, error logs, maintenance schedules, performance metrics. If a robot encounters a problem it can't solve, a human steps in. The human analyzes the situation, makes a decision, and the robot learns from that decision for next time. It's a partnership. One engineer explained it perfectly. Robots are incredibly good at doing the same thing perfectly every time. But when something unexpected happens, when a new problem arises, that's when human creativity becomes essential. We're not competing with the robots. We're teaching them, and they're making us better at our jobs too. Safety is paramount in this factory. Every robot is equipped with collision avoidance sensors. If a human walks into a robot's path, the robot stops instantly. If a robot detects an abnormal force, like bumping into something unexpected, it freezes. These safety systems are tested thousands of times before a robot is certified for operation. Humans and robots share the factory floor safely. Watch this moment right here. A humanoid robot is assembling a complex component, but one of the parts doesn't fit correctly. The robot pauses, recognizing an anomaly. It sends an alert to a human technician. The technician walks over, examines a part, realizes it's slightly warped, and swaps it for a new one. The robot continues working. Problem solved in seconds. That's collaboration. Here's something worth thinking about. As robots become more capable, more intelligent, more independent, will our relationship with them change? Will we see them as tools? As partners? As something else entirely? The answer is being written right now, in factories like this one, and you're watching it happen. One of the most impressive features of these robots is their ability to self-diagnose problems. If a robot's motor starts overheating, it knows. If a sensor begins to drift out of calibration, it knows. It schedules its own maintenance, alerts the human team, and in some cases, even performs minor repairs on itself with the help of other robots. Downtime is minimized. Efficiency is maximized. Every day, the AI system analyzes performance data from every robot in the factory. It identifies patterns, which movements are most efficient, which tasks cause the most errors, which designs need improvement. Then it updates the training algorithms. Tomorrow's robots learn from today's experiences. The factory doesn't just run, it evolves. So where is all this headed? These humanoid robots aren't just staying in factories. They're being deployed in hospitals, assisting surgeons with precise movements. They're working in disaster zones, navigating rubble to find survivors. They're exploring deep ocean environments and distant planets. The technology being perfected here will change every aspect of human life. Imagine a surgical robot with the same precision you've seen today, but working inside a human body, suturing blood vessels thinner than a strand of hair, removing tumors with zero damage to surrounding tissue. These aren't future fantasies. They're already happening. And the robots are being built right here, using the same assembly processes, the same AI brains, the same commitment to perfection. Or imagine these robots on Mars, building habitats, repairing equipment, exploring terrain too dangerous for humans. NASA and private space companies are already testing humanoid robots for exactly these missions. The robot you watched being assembled earlier might one day walk on another planet. The future isn't coming. It's being built right now in this factory. Let me ask you this. Does this technology excite you or worry you? It's okay to feel both. Every major technological leap in history has been met with hope and fear. Fire, electricity, the internet, and now intelligent robots. The question isn't whether this technology will advance. It will. The question is, how will we choose to use it? From an economic perspective, automation like this creates enormous value. Products are made faster, cheaper, and with higher quality. That means more people can afford better technology. It means resources are used more efficiently. It means human workers can focus on creative, strategic, and meaningful work instead of dangerous, repetitive tasks. The economy doesn't shrink. It transforms. Of course, transformation requires adaptation. The workers of tomorrow will need different skills than the workers of yesterday. That's why education is evolving too. Technical schools are teaching robotics maintenance, AI programming, and human-robot collaboration. The jobs aren't disappearing. They're upgrading, and the opportunities are bigger than ever for those who choose to learn. There's another benefit we haven't discussed yet: the environment. Robots don't waste materials. They cut with perfect precision, reducing scrap. They optimize energy use, running only when needed. They enable lighter, more efficient product designs. Factories like this one use 30% less energy than traditional manufacturing plants. Automation isn't just efficient, it's sustainable. Japan isn't alone in this race. The United States, Germany, South Korea, and China are all investing billions into robotics and AI. The competition is fierce, but competition drives innovation. Every breakthrough in one country pushes others to innovate faster, and ultimately, humanity benefits. The robots being built today are the result of global collaboration, shared research, and collective ambition. If you made it this far, you're clearly someone who thinks deeply about the future. I'd love to hear your thoughts. Drop a comment below. Do you think humanoid robots will become a normal part of daily life in the next 10 years? Or will they remain specialized tools? Your perspective matters. And who knows, your comment might spark an idea for our next video. Let's return to the factory floor one last time. The shift is ending. Robots are completing their final tasks of the day. But here's the thing. There is no end of the day for this factory. As one team of robots powers down for maintenance, another team activates. The production line never stops. The future never sleeps. And every hour, more robots are born, ready to build the world of tomorrow. Standing here, watching machines build machines, you can't help but feel a sense of awe for all of human history. We've built our tools with our own hands. Now, for the first time, our tools are building themselves. We've crossed a threshold. We've entered an age where intelligence and capability can be manufactured, scaled, and distributed. And we're only at the beginning. So here's my final question for you. What will you build with this technology? Because these robots aren't the end of the story. They're the tools. You're the story. Your ideas, your creativity, your vision for the future. If this video inspired you, hit that subscribe button. Share this with someone who needs to see it. And stay curious, because the future belongs to those who dare to imagine it. The factory doors close behind us, but somewhere inside, a new robot is taking its first step. Somewhere, a machine is learning something it didn't know a moment ago. Somewhere, the future is being assembled, piece by piece, by hands that never tire and minds that never stop learning. This is not the end of human achievement. This is the beginning of what we can achieve together with the intelligence we've created. The future isn't built by humans or robots. It's built by both, and it's going to be extraordinary.